All right, on to average speed and instantaneous speed. So it depends. Which are we going to use? Which one do we need? If we're talking about the whole trip or if we're looking at one specific. Average speed is calculated over the entire trip. So here's the equation. It is V_av, this little subscript here, average equals delta D over delta T. In this case, this delta D is your total distance traveled over the total time that has elapsed while traveling. So if we're traveling for 40 miles an hour, then and we're doing that for 2 hours, then that change in time is going to be 2 hours. Now, if your average in physics class is 80, or any class, probably not physics class, it's going to be higher. Every single grade you've received is exactly an 80, or you have this distribution where you have some over 80 and some below 80. If there's one grade below 80 and there's others above, you can kind of think of it as a tug of war. Obviously, it's going to skew to the above. If there's one grade above 80 and others are below, that one grade must be much farther below 80. Here's a visual representation of that. So if these little blue dots represent assignments or grades or whatever. If all three of your grades are 80, then your average will be exactly 80. If they're evenly spaced out, then 80 happens to be right in the middle, your average will be 80. If all of your grades are between 80 and 85, that means way down here, we've got to have a super low grade to kind of bring down that average. Because if we throw out that outlier, then obviously our average is going to wind up right about here. Same thing for the positive end of it. We have a little bit lower average, but it's being boosted up by one giant positive grade. If you take a car trip, same thing. If your average speed is 80 miles an hour, then that means you traveled exactly 80 miles an hour for the entire trip, or you sometimes traveled over 80, sometimes traveled below 80. Either way, if you spend a long time going a little bit over 80, then this can make up for a short time going slower than 80. So when you're in the car and you're driving and you're trying to make up time, so you speed, you going slightly faster for a short period of time is still not going to affect your average speed enough. So the average speed is what would win the race, if you want. For swimming, it's not who is the fastest off the block. It's not the first one to get to the other wall. It's whoever has a greater average speed. So you can be fast in some spots, slow in another. Here's a graph where we have speed on our vertical axis, time on our x-axis. This is where we traveled 80 miles an hour the entire time. Maybe we went up to 100 and down to 60, up to 100, down to 60, and it just kept oscillating, going back and forth between those two numbers. Or maybe we started out real slow and then we picked up a lot of speed. Spend a long time going under 80, is slow, then you can make up for the average by going much faster for a shorter amount of time. So back to you driving and increasing your average velocity. If you're speeding, go 10 miles an hour over the speed limit, and you do that for 10 minutes, but your whole trip was an hour, you're not saving that much time. The risk, I would say, is not worth the potential penalty for speeding. Now, if your trip is 20 hours and you're going 10 miles an hour over the speed limit, assuming one speed limit for the entire 20 hours, if you go over that speed limit for a longer time, then that will obviously increase your average velocity. That'll look like that. Uh-oh, what'd I mess up already? If I take the mean of 80, 80, 80, I get 80, so it makes sense. The average is 80. If I take the mean of 160, 160, we're going to get 80, right? So we're good here. But if you take the average of 20 and 100, you get 60, not 80. So the average speed of 80 is not accurate. What in the world am I talking about here? If you take the average of, or the mean of 60 and 140, you're going to get 100, not 80. Right? So that goes back to, it depends on how much time has elapsed that you're going this faster or slower speed. In other words, if you go 50 miles an hour, then 70 miles an hour, the average speed is not 60 unless you spend the same amount of time going 50 and 70. So if you go 4 hours going 50 miles an hour and 4 hours going 70 miles an hour, the average would be 60 miles an hour, the same as the mean 50 and 70. But if you spend 6 hours going 50 miles an hour and 2 hours going 70 miles an hour, now, back to the grade balance, you've got most of your hours stacked up at 50 miles an hour, and then you have a couple hours over here. Your average is only slightly skewed. You spend 2 hours going 50, the opposite happens. Average velocity is like average speed. It's calculated over an entire motion. But average velocity considers displacement, not distance. I might have messed up that video.